actually share my screen too. All right. So when, okay, I'm gonna go with you. When we are talking about dimensional analysis, are you able to tell me what the premise of dimensional analysis is? Or you just know that you have done it before?
No, I just remember hearing it, and then we started talking about science.
Okay, so yes, we just got done scientific notation. And that kind of spills over into dimensional analysis. Okay? In science class especially, but we see it all the time. We will measure things in various units. If we want to measure length, we use meters. If we want to measure mass, we use grams. Okay? But those are some of our base units. We talked about those base units, those SI units early on. Okay, we said there were 7 of them, and really we're going to focus on 5 of them. Well, of those base units, there are also larger and smaller quantities of those units. Who here has heard of a centimeter? That should be everybody. What about a kilometer? Or if you want to say kilometer. Okay? That should hopefully be everyone. Okay, but those are all centered around those base units. But those words kilo or centi or even milli, like milliliter or millimeter, okay? Those are all what we call prefixes, metric prefixes, okay? And yes, my screen is black on purpose. I've got my control here. We use dimensional analysis for a multitude of ways. We use it to compare small objects to large objects based off the same unit, and vice versa. Large objects to small units, small objects to large units, using those metric prefixes. But we could also compare what seemingly appear to be unrelated objects. For instance, we use the measurement of a foot when we talk about distance a lot of times, okay? Or a yard or a mile. But we're one of the few countries really that do that. Everyone else kind of uses, as we talked about, the metric system. And so using dimensional analysis gives us a process in which we can compare and convert. That's the big word right there, convert units mathematically. So that's what we're going to focus on today and tomorrow and Monday. Today we're going to finish our section, we on 3? Section 3 notes? Or section 2? 3? 2. Yeah, we're doing dimensional analysis, but I can't remember if it's section 2 or 3.
Probably 3.
Okay, section 2. We're going to finish section 2. Okay, so you'll want to get your notes out. Okay, it's going to be a very short discussion today. Then I'm going to hand out your homework and another document that we're going to talk about. Okay, this document's going to be huge, hopefully huge for you to use once you kind of get an idea of it. And it's going to be one that you can use on quizzes, tests, yada, yada, yada. All right. So, again, finish the notes today. Do some practice problems today. Do a couple additional problems today. You're going to work on some homework. We're going to come back tomorrow. We're going to discuss our homework. Okay? I still want you to submit your homework. We're going to take it as a completion grade. Okay? So submit it to Classroom, but bring it with you tomorrow. Because we will talk about it. I'm going to be calling for volunteers. Provide answers or solutions. Then, once we've kind of discussed homework, we're going to do some additional dimensional analysis, but this time we're going to take a different approach to it. Meaning, today's problems, we're just going to simply be like, convert this to this. Tomorrow's stuff is going to be similar in nature, but it's going to be in Word format. Okay, things that you're going to be seeing a lot more of. Okay. On Monday, we are going to have a quiz over dimensional analysis. So make sure that you get on to Google Classroom. You do not have to get on a Google Meet. okay? Take the quiz because we set it up in order for when everybody comes back together, and everyone comes back together on Tuesday, we're going to continue on into section 3, okay? So everyone will be all here, present, and happy. So let's talk a little bit about dimensional analysis. It is defined as a systematic approach to problem solving that uses conversion factors to move, or again, there's that big word, convert, from one unit to another. The term conversion factors, okay? That's really all we utilize are conversion factors. Like there are 100 centimeters in 1 meter. There are 1,000 millimeters in 1 meter. Or there are 1,000 meters in a kilometer. Conversion factors are simply just equivalences. Okay? Equivalences that we use to change units. It's a ratio of equivalent values used to express the same quantity, just in different units. We change the units of a quantity without changing their value. Like we say 1 dozen eggs. Really, when we say dozen, we mean 12. Okay, or 3 teaspoons is equal to 1 tablespoon. Or 3 feet is equal to 1 yard. Those are conversion factors. They are equivalent values, but we are changing units. Percentages can also be used as conversion factors where we can relate the number of parts of one component to 100 total parts. So like 95%, it's a ratio of 95 parts to 100 parts. And so, like I said, quick discussion today. Those of you who at least recall dimensional analysis wording, hopefully once we do a couple of practice problems, this will help as well. Okay, before I get into the problems, I'm going to hand out this sheet. And for those of you at home, I'll be showing you on the camera this sheet, but I'm also going to be posting it to my classroom for you to take a look at as well. So give me just a second. Oh,
How warm on there over there?
you can open it up even further.
Yeah,
So
a little bit hot.
No, my legs are kind of cold.
It's a little
It's toasty.
It's kind of toasty.
all right. I recommend you put your name on these just in case it gets left behind or lost and knows where to go. All right. So again, I will be showing you this chart as we talk about it on the screen here once I get my whiteboard. Yeah, that first section, and I'll show everybody at home this. What I'm looking at is this. And again, I'll be posting this PDF version to Classroom, but also you'll receive a hard copy of it tomorrow. So this left column, I blacked out because we don't need it. Okay, it doesn't pertain to anything we're doing. But what I want you to do is familiarize yourself with the symbols, the prefixes, and their values. Some of the more important ones that we are going to really cover go from, we might go from nano to mega. So this area that I am kind of highlighting there, mega all the way down to nano, those are the ones you're typically going to see. Okay? So we've got mega, kilo, hecto, deca. And then where it says none, that's our base starting. Okay? Call it like your home base. That could be your meter, your liter, your gram, any of those SI units, right? All the numbers above where it says none, above your base, those are larger than the base itself. Okay, if you look over here on the far right-hand side, again, starting at that base unit right here, if you look at deca, 10 to the first. Deca is 10 times larger than our base. Okay? So all these are powers of 10. Let's go up to kilo. Kilo is 1,000 times larger than our base. So for instance, if my base is 1 meter, a kilometer is 1,000 times that 1 meter. So how many meters equals 1 kilometer? 1,000. Exactly. 1,000 meters equals a kilometer. But let's go below that. So let's go below the base where you're going to see deci, centi, milli, micro, nano. Okay. Again, get familiar with the symbols. Okay. So if you look at this, these are starting to become fractions of a whole base. Okay. A centimeter is a fraction of a meter. Okay. As you see here, centi, it's 100th of a meter. So how many centimeters equals 1 meter? If 1 centimeter is equal to 100th of a meter, how many centimeters equals 1 meter? Look what I'm doing to the word here. 100. Let's try micro. Okay, let's try again micrometer or micrometer, however you want to say that. Okay, a micrometer is 1/1,000,000th of a meter. So how many micrometers equals 1 meter? 1 million. You see the relationship building from these? And so the more practice you get here, the more comfortable you're going to be getting with it, okay? And so you'll start to recognize that when we say milli or centi or kilo or hecto or anything like that, that we're going to start to associate that with a value, okay? And so using dimensional analysis, we're going to be using these values to help us calculate. So let's go back to the notes here. Yes, ma'am.
Could you use this with scientific
Notation?
Yeah.
Absolutely, because you see here in this column, that's all scientific notation. So absolutely you could. So go ahead.
For an example, if you go 10x into the 6 for your micro, that would be
10 to the -6 micro.
yeah, that would be 10 million.
Yeah. Yeah. So it's, yeah. All right. So let's take a look at some practice here. So question number 1 says convert 48 kilometers to meters. So the very first rule that I'm going to stress to like none other is the very first thing you do to set this up is to always write down the information that you were given. So in this problem, 48 kilometers is what we're given. So that gets written first. So again, for whatever, we're going 48 kilometers to meters. So let's solve this. So rewrite what we know, 48 kilometers. You then are going to multiply by the specific conversion factors. Okay, so we need to go from kilometers to meters. Okay, so very good. So if you didn't hear Caden, that's 10 to the 3rd meters is equal to 1 meter. And it's very important that whatever unit that you are trying to solve for. So for this instance, you are solving 4 meters. That you place that unit in the correct location so that it remains there after you cancel out units. In this case, meters goes up top, kilometers goes on bottom. Because what can I do mathematically? I can cross cancel, right? Now, we were just told that there are how many meters in 1 kilometer? 1,000, or 10 to the third. So we place that, again, 1,000 meters is equal to 1 kilometer. So again, now that I've got set up, my units of kilometers cross cancel. What am I left with? I'm left with meters, right? Is that the unit I'm looking for in my final answer? Absolutely. So I go ahead and solve it mathematically. 48 times 1,000, you get, very good, 48,000. And do not forget your unit. Do not forget your unit. Otherwise, you're going to have to answer to me. Okay? Let's try another one. Convert 245. Can anybody tell me what MS stands for? Milliseconds. Very good. 245 milliseconds to seconds. Okay. So where do we find milli? We find milli right here. It is below your base. So if seconds was right here, milli is down here. So how many milliseconds are in 1 second? You're answering it. You already answered the question, but in terms of our conversion factor, I think you have the right answer. How many milliseconds are in a second? 1,000 milliseconds in a second. Okay, very good. So, as you already told us, but showing you the steps, the very first thing is you write what you are given. 245 milliseconds. But this time, oops, that's not what I want to do. Again, this time you need to make sure you know what unit goes on top. So what unit goes on top in this setup? Seconds, because that's what we want in our final answer, right? Seconds goes here. Milliseconds go here. Okay. They will cancel. But how many? Again, we have 1,000 milliseconds in 1 second. Again, these two equal the same, right? So that's how we can use it. And so we now have our math process where we have 245 times 1 divided by 1,000. David gives us 0.245 seconds. Very good. Yeah, we're getting there. Let's go a step up, just because it's fun. Okay. I heard you say it, Evan. You said this is the best stuff I've ever learned. Yeah. All right, let's look at number 3. What is the speed of 550 meters per second in kilometers per minute? Before I address anything, what is the first thing that we write down? What we know. Okay, I'm just kind of jotting this down again. km per minute. Okay, so this is the problem. We have 550 meters per second. We need to translate that to kilometers per minute. Now, this isn't as crazy as it seems, okay? You can do this a couple different ways. I'm going to show you the way that I kind of prefer to do it. You might have some other way you like to do it, like as you kind of deal with this, okay? So, as we said, the first thing is you write down what you know. 550 meters. And see how I'm writing this? Kind of just making it a little tidier. Okay, meters over seconds. Okay. Now, when you have two units that you need to convert, focus on one at a time. So, first one I'm going to focus on in this case is the meter. I'm going to pretend that that seconds unit isn't even there. Okay? So, I need to go from meters to kilometers. Okay? First off, what unit has to go on top in this case? km. Very good. Because we need to cross cancel. Okay? How many meters again in a kilometer? 1,000. So we put 1,000 here. Okay? So now look, we've already taken our step to go from meters to kilometers, right? So we kind of shift our thought a little differently. This time I pretend that that meters unit isn't there, and I address the seconds. Okay? But we're going from seconds to minutes. This time, who goes where? Thinking that we have to cross cancel. Very, very good. Seconds goes on top. Minutes goes on bottom. Which means that our seconds cancels, but we still have a conversion factor we have to put in there. How many seconds go in a minute? You were thinking an hour, weren't you? Yeah. We have 60 seconds per 1 minute. So here's where you come in with your calculator extreme skills. We need to solve this one. So let's talk about the steps in your calculator. I always, after you do a single step, I always encourage you hit the equals button. Okay? So 550 times 1, you don't have to do that one in your calculator. I think you can do that in your head, right? So 550 times 1 divided by 1,000. Hit equals. Then you just simply hit multiply by 60. And so calculate that. Let me know what you get. Don't forget your units. Hope you all have some calculators out there. Today you can use your phones, okay? Today you can use your phones. For calculating reasons, that is. 33 kilometers or kilometers, however you want to say it, per minute. So again, anytime you come across a second or a problem where you have to change two, you literally use your hand to cover up one of them. Focus on one at a time. Okay? Once you've gotten to the area, see I've already got it here converted to what I need, then cover up that first one. Focus on it. Again, cross cancel. Removing the units we don't need anymore and only leaving the units that we must have in our final answer. That's going to be huge when it comes to putting this in the correct location, okay? Questions on this? Now that we've done a couple of examples, those of you who somewhat remember dimensional analysis, is it starting to come back a little bit? Good. So, those of you at home, you should have, it's not posted. All right. I am now going to post the homework for you in just a second. So you will complete this and submit it back to classroom when you're done by tomorrow evening. Hold on, I gotta set this up. So actually, I'll do that here in a second. So you can sign off unless you have other questions. Yes. Yes.
Yeah, I'll 22 seconds away from messing up. Like so close. You gotta wait for me a minute. He said, you people that on the meet, this one.